Here we will discuss about supply chain management. In supply chain management, the main important concept we will discuss is just-in-time inventory, okay, and lean manufacturing. Then and just-in-time inventory is where the concept is we don't keep inventories in stock. Whatever we need, we order it, we collect it, we do the production and we sell it up. We don't have a storage space, we don't store anything. That's the concept in just-in-time inventory. Then lean manufacturing is where we try to avoid wastages. Okay, maximum wastage we avoid. Then we will discuss about enterprise resource planning, ERP. Okay. Then we will discuss about theory of constraint and throughput costing. Theory of constraint is that inside a process, if there is a slow moving process is there or a slow process is there, first we have to fix that process rather than working on total quality or total process. It will not give you any value addition. So first we will fix the constraint, then we'll go to the next constraint. Then the capacity management. So yeah, going forward. Just-in-time inventory. So supply chain management involves a two-way exchange of information. That means like we take information from the customers and same time we take information from the customers and we take information from the suppliers also. Right. Sometimes what happens when you do ordering through Amazon, you will know how much quantity Amazon has. And even Amazon also will know how much quantity you want. You might search for foreign quantity. They have only four. So sometimes what happens, they will send you a reminder. Okay, alert. We have additional quantity now. You can order it. So same. That's what the two-way exchange of information. For example, a customer may be able to track the process of its progress of its order, and the supplier may be able to monitor the customer's inventory. Okay, thus, the customer has better information about order availability, and the supplier knows when the customer's inventory needs replenishment. Just like we do the courier. When we send a courier, we can track where the courier is. Right. Next, the modern inventory planning favors just-in-time model, JIT. Many companies have traditionally built parts and components for subsequent operations in a present preset schedule. So what happens, even if it's in a preset schedule, whether the process 2 or process 3 is working or not, the process 1 will produce whatever they are required to produce. So what happens now? Process 2 is not processing. Okay, so this whatever the process 1 have done, it will pile up. Got it. So in just in time, it will not happen. Next, then such a schedule provides a cushion of inventory so that the next operation will always have parts to work in with just in case method. Okay. Then in this respect, traditional inventory planning views inventory as an asset. So normally companies see inventory as an asset, right? In financial terms also, we consider it as an asset. In costing side also, they might consider it as an asset because we have something for the future. But in just in time, we consider inventory as liability. Why? Not in literally in terms of books of accounts, we are saying liability. It's an obligation for us. If we overproduce it, we have to stock somewhere. We have to protect the inventory. We have to insure it. Okay, we have to, if we need a cooling system, we have to provide the cooling system. So it's a liability for us. It's an additional cost burden for us.
But in time,
Yeah.
we are preparing the things
Yeah.
to make the things at the same time. Right?
Same time. So
it will not be a liability for us, right?
no, so that's right, because we don't store anything.
Yeah.
For example, I am in the production. So you are my supplier. Today I need 10 quantities, then I will call you and say, okay, I need 10 quantities. So you will send this 10 quantities to me and do my production. So I don't need to store somewhere. Why I'm doing this? Because I consider inventory as liability. If I store it, it's a burden for me. I have to put a security.
Yeah. If we store, that will be a liability for us.
That will be a liability. That's why in just in time we consider inventory as a liability. So that's why we don't store. We don't want liability.
We consider that as a liability.
Liability. Correct. That's why we don't keep it. Now, so modern inventory planning favors the just-in-time model. Many companies have traditionally built parts and components for subsequent operations as a present schedule that's we read, right? Okay, so now in contrast, just-in-time views inventory as a liability and limits output to the demand of the subsequent operation. So whatever the next operation need, that much only we will produce. Reduction in the inventory levels results in less money invested in idle assets, reduction of storage space requirements, and lower inventory taxes, pilferage, and obsolescence risk. Just like you take the order before you cook some.
Yeah.
Just in time is a reaction to the trends of global competition and rapid technology progress that have resulted in the shorter product life cycle and greater consumer demand for product diversity. So because people need different kind of products. Today I might drink tea. Tomorrow my mood is for coffee. Okay. So if someone is selling tea or coffee, for example, you are selling tea, both you are selling. So you know I'm a permanent customer. I always come and ask for tea. What if today I come and ask for coffee? So your tea will be wasted. So you don't keep stock. No. So high inventory levels often mask production problems because defective parts can be overlooked when plenty of parts are available. For example, you have a lot of goods at home and you're looking for one of your credit card. So you have to search everywhere. What if you don't have any other stuff? Only the cards are kept in one place. It is easy to get that part. Yeah. So that's why high inventory levels often mask production problems because defective parts can be overlooked when plenty of good parts are available. If only enough parts are paid for the subsequent operations, however, any defects will be immediately halt production. So if there is a defect when through in the process of production, you will stop that and you will fix it, or you will remove it from the process. If you don't remove, what happens? The same product will go to the next process. For example, if it's a car, I'm a car manufacturer. One of the cars frame I have done. This frame has broken. I'm not checking the quality at every process. So this frame, the broken frame, will go to the next phase, and it will be painted, tinted. The seats will be fitted. Last, when the product come outside, then they will understand now whatever they have done is waste. That's why in just in time we will stop the process and remove the product. Either if you can fix, we will fix it. So the focus of quality control under just in time shifts from the discovery of defective parts to the prevention of quality problems. So zero machine breakdowns and zero defects are ultimate goals. Higher quality and lower inventory go together. Yeah. Next comes the lean manufacturing. Okay, lean manufacturing expands the concept of just in time. The central focus is on accomplishing more with fewer resources. That means fewer labor, equipment, space, etc. Providing customers with what they want and meeting their expectation. So in Lean Six Sigma, what happens? What happens? Yeah. Sorry. So in Lean Six Sigma, not Lean Six Sigma, Lean manufacturing. Okay. Lean manufacturing, what happens is you will not use that much labor and material as in the just in time, because here you start your production by knowing what is to be sold. So your requirements will be limited. So the first thing you will see is the value. What value the involves identifying the features of the product or services that are valuable to the customers. So when you know what the customer needs, you will eliminate non-value added cost. Okay. That value stream requires examining every process with the production of a product. Within the production of a product, then identifying process that add value and removing processes that do not add value. Clear. Next, flow and pull. Incorporates designing the production process to be capable of maximizing the flow of the product initiated by the pull of customer demand. Pull of the customer demand. Only products that what the customer wants only will be produced. Okay. Then this is where lean manufacturing and just-in-time principle coincide. See, for example, here, even though it is a mass production, still we will check how much is the customer requirement. Let's say, for example, nowadays, if you go for a new car, does you get a new car on the same day? 5 years back or 10 years back, when you go to a automobile showroom and you pay your money, they will instantly give you a car key. Now you will go, you will place the order. What they're doing is the lean manufacturing. So they will take your order and they will say, okay, there's a waiting time of 3 months. Now they will inform, okay, you want a car. This will avoid, like what we say, they will know what kind of car you need, what is the specification. Okay, it's a top variant or the lower variant, whatever the thing. Now that's what the pull demand. Pull means the customer is pulling the product. Push demand means just like Lay's, Pepsi, and all. They produce 1 million product. They will push to you. How they push? They put offers. Buy one, get one free and all. Why? Because they have already produced. So now they have to push it out of the warehouses. Now, next, empowerment. Empowerment is where, see, for example, in just in time, what I said, you're in the production and in one process, if you want to figure out this particular product is defective, those employees who is standing in that process should know, okay, this is a defective product. Otherwise, what happens? There will be a quality team. The quality team will not be in the all process, right? He will be in the end of the process. So once the goods reaches him only, he will understand, okay, this is a defective product. So by empowering, what we do is we teaches the employees how to figure out which is a defective product and which is not, and also we will train them to fix any problem at that point. That's the empowerment. Okay, so empowerment provides each employee with the knowledge and authority to make valuable and timely decision in order to add customer value and eliminate waste from the process. Yeah. Next. Perfection focuses on making incremental improvement in each process with perfection as the goal. Okay. Next comes the Kanban system. So, just in time is a total system of purchasing, production, and inventory control. Kanban is one of the many elements of just-in-time system. So actually, this Kanban system and just-in-time system was developed by Toyota. So what Toyota does is, if they start a factory here, for example, in Abu Dhabi, they will bring couple of suppliers also. They are going to start a factory here, main factory, assembling factory here. They will be asking their suppliers, they will be having only limited suppliers, 10 or 50 trusted suppliers they will have. So this 20 or 30 suppliers will start their factories around the main factory of Toyota. So whenever Toyota needs some raw materials or accessory, they will ask them and they will bring at the time. So just in time will happen. Ultimately, even if one company is following just in time, it doesn't mean that the whole world is following just in time. For example, you are my supplier and I need 10 quantities, then you should store, right? You can't go and start production at that time. So here, ultimately, what happens is I am putting that burden on you people as suppliers. Yeah. Now, so just-in-time system and was developed by Toyota Motor Corporations. Okay. Then Kanban means ticket. So tickets are described as cards or markers. So here what happens? Toyota, for example, if I am Toyota, I need 10 tires. So I will put in a paper, need 10 tires. So this will be handed to you. Once you get this, you will deliver it. This is a Kanban system, very fast. Otherwise, what happens? If it's a normal purchase scenario, my manufacturing manager or the factory manager should request the purchase department. We need 10 tires. So he will wake up from the sleep and process the PO and he will send to you in 2 days. You will get after 3 days. You do the production, you send it after 5 days or 10 days. So this delay is avoided by just one ticket. So this ticket is the like PO or authorized paper. This doesn't need any manager's signature, nothing is needed. If you have that, you can deliver. Now, Kanban means ticket. Ticket also described as cards or markers. Control the flow of production or parts so that they are produced or obtained in the needed amount as the needed times. The basic Kanban system includes a withdraw Kanban that states the quantity that a later process should withdraw from its predecessor. Okay, so your output Kanban is my input Kanban. Got it? So your output is 10 tires. So you are giving it to me with this Kanban ticket. So this is my input Kanban. Clear? Yeah. A production Kanban that states the output of the preceding process, and a vendor Kanban that tells a vendor that what, how much, where, and when to deliver. No. Kanban is especially a visual workflow management system. When a worker sees a Kanban, the card or ticket act as authorization to release inventory to the next step. Work cannot move in the next stage until a Kanban indicates the next stage is ready for it. Clear? Until I ask, you will not deliver your product. Next. US companies have not was not comfortable with controlling production using tickets or production flow, because long back itself they started using computers in the production. So they don't want this paper tickets at all. So computerized information system have been used for many years, and US companies have been reluctant to give up their computers in favor of this essentially manual Kanban system. Instead, US companies have integrated their existing complex computerized planning systems with the just-in-time system. Next. Objectives. So higher productivity. The using of just-in-time or Kanban will give you higher productivity, reduced order cost, okay, as well as carrying cost also. Then faster and cheaper setups, shorter manufacturing cycle times, better due date performance, improved quality, and more flexible process and objectives are the objectives of just-in-time method. Then the ultimate goal is increased competitiveness and higher profits. Features. Just-in-time is a pull system. Not a push, it's a pull system, because depends upon the market analysis. After doing the market analysis or requirement in the demand, then only we will start the production. That's items are pulled through production by current demand, not pushed through an anticipated demand. Now, one operating process produces only what is needed by the next operation. Okay, and components and raw materials arrive just in time to be used. Then demand-driven production always allows inventory levels to be minimized. Counting, handling, and storing inventory are viewed as non-value added. Clear? Then, indeed, carrying inventory is regarded as a symptom of correctable problems such as poor quality, long cycle times, and lack of coordination with suppliers. Then, organizations that adopt just-in-time system frequently experience a decrease in the number of suppliers. Why? Because if they are taking codes from 10 or 100 suppliers, it will take a lot of time. So they will have dedicated suppliers for them. Next. Then buyer supplier relationship are facilitated by EDI, electronic data interchange. Like I think you might have seen, I think ADNOC have this. Okay, ADNOC and few companies use here in UAE. That is, you log into their system and fill the PO details and all those things. Have you seen that? No. Okay. Like supplier and buyer and the supplier will have a dedicated online system. Where when you send the goods to me, you will put the say invoice details, everything there. So I will get intimation on the same time. But when I need some inventory, I don't need to email you. I just log into or automatically from my system, the PO raises to you. Clear. So here a technology that allows the supplier access to the buyer's online inventory management systems. Thus, electronic messages replace paper documents, that is, purchase orders and sales invoices, and the production schedules and deliveries of the parties can be more readily coordinated. So, by using just in time, what are the effects we will see in the operations? One consequence of lower inventory levels associated with just-in-time system is elimination of the need for certain internal controls. So we don't need POs. We don't need approvals from each and every managers. Next, frequent receipt of deliveries from suppliers often means less need for a sophisticated inventory control system and for control personnel. So we can cut down the employees also. We don't need a storekeeper. We don't need a security guard. That just-in-time also may eliminate central receiving areas, hard copy receiving reports, and storage areas. Then manufacturing lead time is reduced. Then, as a result, on-time delivery performance and response to change in markets are enhanced, and production of customized goods in small lots becomes feasible. Then production setup cost and times per lot are reduced. However, because smaller lots are used, total setup costs are not necessarily lower using just-in-time production system. See, if you are producing rather than okay, when we were kids at home, we used to see this. Even from the ADDC also we see this, right? If you are not using a light, off it. If you are using after 5 minutes, off it and on afterwards. If you switch off and switch on immediately, the current or electricity consumed is more. So if you are starting a machine and you do 10,000 unit production, and if you're using a machine, you use 1,000 units, then you off the machine, again you start, do the next 1,000, it consumes more energy. Okay, that's what. So production setup cost and times per lot are reduced. However, because smaller lots are used, total setup costs are not necessarily lower using a just-in-time production system. It means total setup cost will be higher. Then the quality of parts provided by suppliers is verified by use of statistical records rather than inspection of incoming goods. Okay, storage, counting, and inspecting are eliminated in effort to perform only value-adding work. Clear?
That is showing the advantage and disadvantage.
Yeah, advantage and disadvantage. So this one, statistical control is one advantage actually. For example, I don't know, you might have seen in Discovery Channel or something. Okay, from a Apple farm, they collect, or even the McDonald's also. What they do, they don't take all the potatoes for the French fries. They will take only the potatoes which is of a particular length. So what they do is they will plug all the potatoes and put it in a conveyor belt. And when this belt goes, what happens from the belt itself, it sort out the bigger potatoes and the smaller one will be segregated outside. So this is one statistical control. Why? Because we have informed the computer or the belt that okay, we need only the potatoes which is of this size. Clear? No. Implementing just in time. So how we will set up a just in time system in our organization. To implement a just in time inventory or lean production system, manufacturing is reorganized around what are called manufacturing cells. So now we might be seeing manufacturing as a single process. Now we will divide it into different processes. And each processes we will consider it as a separate entity or separate unit. And these units, whoever working in this particular unit will be aware of everything, A to Z. For example, I am the operator of this particular machine. And for example, this is a 10 machine process. So there is 10 people, operators are there. So each of these operators will be trained about the quality of the output, how to maintain the machine, everything will be trained. Clear. So this will be a separate unit and I will be responsible for the whole part which I am handling. Now we will consider it as a separate manufacturing cells. Then, in a conventional plant layout, each department or functions operates specialized machines that perform one task. All work move from department to department. Okay. In a cellular layout, each cell is a miniature manufacturing plant. Clear. Uh, Cells are set of machines often grouped in semicircles that produce a given product or product family. So why they say in semicircles? Because we are talking about a workflow. So, and for example, in this particular area, we do a small process. Maybe this small process will form together a big process, but still we will round it as one single process. So each process will have their own quality checks. Clear. Yeah. So each worker in a cell must be able to operate all machines and possibly to perform support tasks such as setup activities, preventive maintenance, movement in work in process within the cell, and quality inspection. Yeah. Next, in such a pull system, workers might often be idle if they are not multitask. Clear? If, for example, if you are putting in as each process as each cell, if I am not trained, I will wait for someone else to come and check the quality. Clear? Now, a cellular organization requires workers to operate as effective teams. So employee empowerment is crucial in a just-in-time inventory system or lean production system. Greater participation by employees is needed to achieve the objectives of continuous improvement and zero defects. So they may, for example, have the power to stop production to correct a problem, be consulted about changes in the process, or become involved in hiring co-workers. Thus, managers in such system usually play more of a facilitating than a support role. Okay. Enterprise resource planning and outsourcing. Okay. Mhm. So now here, what we are going to discuss is a push system. Okay. In push system, what happens is we figure out the demand and or we estimate a demand and we start the production. Like for example, we estimate that okay, we forecast we will sell 1 million lace chips this year. So 1 million is put into the system. 1 million is the production output we need. So on that basis, the backward calculation starts. Then how much raw materials we need, how much packing covers we need, and what is the delivery time of the packing covers, how much delivery time it will take for the potato or other raw materials. So this will be backward calculated and we'll figure out when we should place an order. If I need to sell something on January, when I need to start the production. Okay, so this comes from the material requisition planning, okay, or we call it as MRP. Okay, now short-range tactical or operational plans must be converted into specific production targets for finished goods. Like for example, if I sometimes what happens, companies used to plan for next 5 years, right? Out of that, from the next 5 years plan, they will break down to each year what is the target. From each year, they will come down to each month what is our target. From months, they will that will be the dollar value. From that, they will figure out how much quantity you have to sell. Okay, now they will figure out how much is the input we needed and all those things. So the raw material is going into the creation of this end products must be carefully scheduled for delivery. Now, the yearly, quarterly, or monthly numbers and styles of finished goods called for the demand forecast included in the operational plan must be turned into specific dates for completion and availability of for shipment to the customers. This is the task of the production master production schedule or MPS. Okay. So if I say I need to sell 1 million lace chips this year by December 31st, then I need to decide in each month how much I need to sell. So in the master production schedule, I will define at what date, in a particular date, I have to put a purchase order for the raw materials. And in a particular date, I have to complete the production. In a particular date, I have to pack it and send to the customers. Now, next comes the material requirements planning. Okay. MRP is a computerized system for moving materials through a production process according to a predetermined schedule. Okay. An MRP system enables a company to efficiently fulfill the requirements of the MPS by coordination coordinating both the manufacturing of the component parts for finished goods and the arrival of the raw materials necessary to create the immediate intermediate components. Clear? So MPS will say on this particular date, I need to deliver, but it is not saying what thing is to be delivered. Or in a particular date, I need raw materials. What raw materials, how much quantity, that MPS will not say. That MRP will give you the details. Clear? Now, um, so as computers were introduced into manufacturing, it was common for firms to have a production scheduling system and an inventory control system. So MRP joins the two into single application. Okay. The three overriding calls of MRP are the arrival of the right part in the right quantity and right time. MRP is a push system because we decide how much we want to sell and we push to the customers. Okay. That is, the demand for raw materials is driven by the forecasted demand for the final product, which can be programmed into the computer. For example, an automobile manufacturer need only tell the computer how many autos of each type are to be manufactured. So automatically the system will calculate backward and decide how much steel it need, how much tires it need, and those things. MRP in effect creates schedule of when items of inventory will be needed in the production departments. If parts are not in stock, system automatically generate a purchase order in the proper date. Okay, considering lead time, so that delivery will arrive on time. So this ordering level is called reorder quantity level, right? Have you studied this word? Reorder quantity. Reorder quantity level is the level at which the system will automatically generate a PO. Okay, so this will be including the lead time. Then what to do? Okay. No. The time of delivery is vital to avoid both production delays and the pileup of raw materials inventory that must be stored. If your goods is arriving 2 days early, also you have to store. If the goods arrives late, also it will affect your production. Next, the MRP system concerns the bill of materials. Okay, a record in which how many sub assemblies go to the finished product. The system then generates a complete list of every part and component needed. Okay, see, I will tell you this in a simple way. Okay, you have some visitors at home. Okay, so okay, you are bringing your friends to home. So you will tell your mother to prepare some food for them. For example, easy biryani. So you will tell her, okay, tomorrow my friends will come. I need 10 biryanis. Okay. So that was the master production schedule. So mom will know tomorrow we need 10 biryanis. Now on that basis, if you want to deliver a biryani tomorrow afternoon, she have to start her cooking tomorrow morning. So that she should buy products today itself. So that comes in the material requirements plan. What she should buy, how much quantity she should buy, it depends upon bill of materials. Sorry. Depends upon bill of material. Like rice how much, chicken how much, spices how much. It depends on the bill of material. Clear? Next. Here, there's an example. So when you see this kind of questions, you don't try to read and understand what is mentioned there. Like here, for example, a manufacturer has a following bill of materials for its main product, AA115. If you see something, if you read like that, you won't be concentrating on the question in the examination. You will read, they have a main product A. Okay, it has two units, subunits. That means raw materials need two components, that is C and P. P how much you want one quantity, and P how much you want five quantity. If you get five P's and one C, you will get a one full A. Clear? Now, to get one C, you need a T, you need two T's and three X. Got it? Clear? And to get one P, you need to have one L. Clear? You're getting it right? Or you could say, okay, I'll put it as an example. If you want to manufacture one car, okay, you need 5 tires and one engine. More clear? One tire is stepping. Okay, so 5 tires and one engine you need. To get one engine, you need like for example, uh, 3 engine parts and one bushes. For example, 2 bushes you need. And for the tires, you need rubber. One sheet of rubber is needed for one tire. So now it's more clear, right? Now, currently in inventories, you have CM how much, or what we say, you have 25 engines. Okay, I'll convert it as it is. 25 engines and you have 35 tires. And you have rubbers at 50 and engine parts, a bush and some other thing, 30 and 40. Clear? Now what happens? The company has 20 units of the finished goods inventory. That means 20 cars they have, okay, in inventory and wishes to maintain the inventory level throughout the year. So they want to maintain a level of 20 inventory. So what happens? Production of 40 units is scheduled for the upcoming month. They're going to produce 40. That means 20 you have to maintain as inventory also. Clear? Now, going forward. So you are going for the production of 40 cars. So to manufacture 40 cars, you need 40 engines. And you need 200 tires. Out of this, you already have 25 engines and 35 tires. Correct. So what you need now is 15 engines and 165 tires. So to manufacture 165 tires and 15 engines, you need again more components. Correct. For that, 15 engines, you have 2 parts, right? Engine 2 into 15 and 3 into 15. Okay. 30 and 45 is what you need. Clear? 2 parts of the engine. Out of this, you have 30 and 40. T and X, you have 30 and 40. So you don't need to purchase anything of T, but you need to buy 5 X's. Got it? Next, for the tires, you need 165 tires. So 165 into 165. Out of this 50 you have. So 115 tires you need to buy. Now you know how much quantity you need to purchase. Clear? So for each of the product to manufacture or to get delivered, there is a time lapse or time lead time is there. That is for engine 2 weeks. Okay, engine part 1 week and next engine part 2 weeks. Tires you need 3 weeks and the tires parts you need 1 week. And the whole product, if you get all these products, okay, to assemble it together, you need 1 week. Now, so when you should start your production? Okay, let me tell me how much week you need to complete the production from 0 to complete production. See, yeah, how many weeks from this? Tell me. Try to assume and say.
We need to take all this into consideration, right?
All these. Okay, so how much according to you? 2 plus 3, 2 plus 1, 3. 3 plus 5, 8, 10 weeks. So you will take 10 weeks to complete. This is how a normal person thinks. So when you put it into this MPS or what we say MRP system, it will show you how much days you need, in how much weeks it will be completed. So when you have to, so it will complete in 6 weeks. 6 weeks it will complete. How? I will tell you. Okay. Okay. So 6th week, or for example, you are counting backwards. You put 1 day. You need to manufacture 40 cars. So in a week, you are going to start completing your production. So 1 week before that, you have to start the production. So X minus 1. That means the completion date minus 1 week. So this is where you start your production, right? Okay. To start your car's production, what you need? You need 165 tires and 15 engines. Okay. So that will be ready by fifth week. Correct. So when once you get these two items, you will start your production and you complete. Okay. Now to get 165, how many weeks you need? For PR 175, right? For the tires, how many days is the lead time? 3 weeks. Okay. So when you place your order here, okay, here, okay, three, you want on fifth week, so -3. So in the second week, you have to place the order. Got it. Again, for the other product, which is you need is engine, right? For the engine, how much days? 2 weeks, right? Hi, sorry. I think there was a connection issue. Okay, so you're getting right?
Yeah.
The concept. So you need on fifth week, you need 15 quantity. So you need to place at least 2 weeks before for this quantity. Clear? Okay. And to get C, you need two raw materials, right? To be completed before that. Out of this T, you don't need, you already have it. And so you don't need to plan about that. Yeah, stop. So to get CM or engine 15 on third week, you need some lead time for that. That is how much? X. You need 2 weeks. So if you want on third week, you have to get your X on the third week. To 2 weeks before, you have to place an order.
Yes.
So you got the concept. So this is how you saved your 4 weeks by properly planning. That means you can do simultaneously multiple things together. Got it. So when you place the order for, okay, I'll give you another example. What if you placed all the orders together? What will happen? All the goods will come and pile up. So you placed your order for L 150.
They will purchase.
Place the order means they will place the order and will get delivered on 1 week or 2 week, whatever the time period. So for example, here in this case, they put the order, they will receive this. When they receive it itself, it is used for the next product's input. Got it? So when this complete itself, it is used for the next product's input. So they don't need to store anywhere anything. But what if you ordered this at the same time you ordered this and you ordered for the other product also? Yeah, for first thing you won't have the things to produce, but what happens? For example, here these things have to wait. You will get this L on second week, but you don't get the X on the second week. You need to wait for 1 more week. So you have to store this somewhere. Then only you can go for the next production. Clear? So when items of inventory will be needed is determined by the lead time and the lead times of other components, items or procedures. The lead time is the amount of time between when a process starts and when it is completed. Okay. Lead time is when the process starts and the process completes. Now, once it is known how many of a final product is necessary, the lead time of all the included components and process can be used to create a schedule outlining when certain items and components must be ordered or produced so that the final product will be completed on time. Some benefits of MRP are reduced idle time, lower setup cost, then lower inventory carrying cost, you don't need to store anything, then increased flexibility in responding to market changes. How? I will tell you. For example, if you're planning earlier and you came to know you don't need 40 units, when you change it here to 35, automatically all the quantities will change. you will get instantly how much quantity you need to order. Yeah. Or for example, after first week, after you placing the order for L and X, you came to know you need only 35 quantity to sell. So suddenly what you will do, anyway, these products are going to come. You will reduce the requirement of product P. At least you could reduce there. Clear. Next comes manufacturing resource planning, MRP2. Okay. MRP2 is a closed loop manufacturing system that integrates all phases of manufacturing business, including production, sales, inventories, schedules, and cash flows. So the same system is used for both the financial reporting and managing operations, because manufacturing resource planning encompasses materials requirement planning. MRP is a component of MRP2 system. Clear. So, means MRP2 is a wider aspect. Then comes the traditional ERPs, enterprise resource planning. MRP is a common function contained in ERP. As we know, ERP is a wider scale than any MRP, right? So MRP and MRP2 is only concerned about the manufacturing, like procurement, all those things. But when it comes to the ERP, it will add your HR, maintenance department, all the other things also. So although ERP and MRP are similar, they are not interchangeable since ERP includes functions not included in MRP. An ERP system allows a company to determine what hiring decision might need to be made or whether a company should invest in new capital assets. A company that merely needed to maintain inventory and materials levels would only need to implement an MRP system. Then the traditional ERP system is one in which subsystems share data and coordinate their activities. ERP is intended to integrate enterprise-wide information system across the organization, that is accounting, supply chain, treasury, etc., by creating one database linked to all the entities applications. So even though we say ERP systems we use in many companies, we doesn't use it. Some companies they have a separate software for HR. We call it HR's ERP. They have accounting's ERP, operations ERP. But the real ERP means is a combination of all these together in one data, single place. No. If this marketing receives an order, it can quickly verify the inventory is sufficient to notify shipping to process the order. Otherwise, production is notified to manufacture more of the product, resulting in an automatic adjustment of output schedules. Clear. If materials are inadequate for the purpose, the system issues a purchase order. If more labor is needed, human resources is instructed to reassign or hire employees. The foregoing business process should interact seamlessly in an ERP system. Okay. Moreover, current generation of ERP system also provides the capability of smooth interaction with the business process of external parties. So this same concept, Microsoft Dynamics. Yeah, you're using that. Okay, actually, if you're using the full version of Dynamics, it will cover all these areas. If you place an order and if you don't, if you have the product, automatically the process shipment will be processed. If you don't have the units, then it will inform the production department. Okay, we need this order to produce it. If they don't have adequate quantity, automatically system produces a PO. And even though the PO is raised, you need more humans. So HR will be notified. So all these things are there in your system.
All these things are there, but we are just using only finance.
You're only using finance, yeah. That's the problem. Okay, so the subsystems in a traditional ERP systems are internal to the organization. Thus, they often are called back office functions. Okay, the information produced is principally intended for internal use by the organization managers. Because ERP software is costly and complex, it is usually installed only by the larger enterprises. However, the mid-sized organizations are increasingly likely to buy ERP softwares because of the budget constraint. You are using only accounting versions. The tremendous variety of forms that information system can take, the diverse needs of users have led to the concept of information resource management, IRM, which takes a global view of the information holding and needs of the organization. This view is promoted by the Information Resource Management Association. Not really needed that part. And generally, separate financial and non-financial system have the increased potential to experience different reporting results, like recurring personal to research discrepancies instead of actually enhancing operations, inefficiencies, lack of standardized purchasing among departments, that is, departments as a whole, not taking advantage of quantity discounts. Like, for example, if you are considering each department separate, they will place their own orders. For example, even if the stationery department A, all of them need pen, but everyone need only one or two pen. But ultimately, as a company, they might need 1,000 pens. If you are buying 1,000 pen together, you will get quantity discounts. ERP connects all functional, financial, and non-financial subsystems like human resource, financial accounting system, production, marketing, distribution, purchasing, receiving, order processing, shipping, etc. And also connects the organization with its suppliers and customers. Okay.
How it connects with the supply.
For example, if you're talking about Amazon, assume I don't know what happens inside Amazon. What if you are searching for a computer, HP laptop? You search, if you find one, you will purchase. It is there, you can purchase. So here it is connected to the customer. Clear. Also, sometimes what happens in the back end, Amazon is not the seller. Maybe, there may be different other sellers inside the Amazon. So you purchase from laptop. You might be purchasing two laptops. One is from Mr. X and one is from Mr. Y. But for you, it is from Amazon. Amazon in the back end, what does Amazon does is it is communicating to you as well as communicating with the supplier also. Yeah. Next. So thus ERP facilitates demand analysis and materials requirements planning. By decreasing lead times, it improves just-in-time inventory management. Even more importantly, ERP's coordination of all operating activities permits flexible response to shifts in supply and demand. Advantages. Okay, we will continue advantages next week. Yeah. Okay. Yeah, it's fine. Okay, Glenda and Maria, thank you. Any queries as of now?
Nothing, sir, for me. Thank you for today.
Yeah, nothing as well.
Okay, thank you. Bye.
Okay.